The Servlet Container Model. Exam Objectives. 3. 1. For the Servlet Context Initialization Parameters. Write servlet code to access initialization parameters. And create the deployment descriptor elements for initialization parameters section 6. 1 and 6. 4. 3. 2. For the fundamental servlet attribute scopes request, session, and context. Write servlet code to add, retrieve, and remove attributes. Given the usage scenario, identify the proper scope for an attribute, and identify multi-threading issues associated with each scope. Section 6. 2 and 6. 5. 3. 4. Describe the web container lifecycle event model for requests, sessions, and web applications. Create and configure listener classes for each scope lifecycle. Create and configure scope attribute listener classes. And, given the scenario, identify the proper attribute listener to use. Section 6. 3. Introduction. Within a web application, all of the servlets share the same environment. The servlet container exposes the environment to the servlets through the JAVX. Servlet. Servlet Context Interface. The Servlet API also defines interfaces that allow the servlets and the servlet container to interact with each other. In this chapter, we will learn about these interfaces, and we will see how to configure the environment using the deployment descriptor. We will also examine the behavior of the servlets and the servlet container in a distributed environment. 6. 1. Initializing ServletContext. Every web application has exactly one instance of JAVX. Servlet. ServletContext, assuming that the servlet container is not distributed across multiple JVMs. The context is initialized at the time that the web application is loaded. Just as we have initialization parameters for a servlet, we have initialization parameters for a servlet context. These parameters are defined in the deployment descriptor of the web application, contained within a context param element. Here is an example. Web app. Context param, param name. dburl. Param name, param value. JDBC. Detable. Param value, context param. Web app. The servlets of a web application can retrieve initialization parameters like these using the methods of the servlet context interface, shown in Table 6. 1. Table 6. 1. Servlet context methods for retrieving the initialization parameters. Method description. String getInit parameter string name returns a string containing the value of the parameter, or null if the parameter does not exist. Java. Util. Enumeration getInit parameter names returns an enumeration of the names of the context's initialization parameters. The Servlet context initialization parameters are used to specify application-wide information, such as the developer's contact information and the database connection information. Of course, before we can use these methods, we must get a reference to Servlet context. The following code snippet from the init method of a servlet demonstrates this. Public void init ServletContext context equal getServletConfig. getServletContext. ServletContext context equal getServletContext. String dburl equal context. getInit parameter dburl. Use the dburl to create database connections. The servlet context object is contained in the ServletConfig object. The previous code uses the getServletContext method of ServletConfig to get the servlet context. You can also use the getServletContext method of the generic servlet class. Generic servlet provides this method since it implements the ServletConfig interface. Note there is a difference between ServletContext initialization parameters and servlet initialization parameters. ServletContext parameters belong to the web application and are accessible to all servlets and JSP pages of that web application. On the other hand, servlet initialization parameters belong to the servlet for which they are defined, and cannot be accessed by any other component of the web application. 6. 2. Adding and listening to scope attributes. You can provide a servlet context with initial parameters inside a deployment descriptor, but you can't add them programmatically. If you want to add objects to a scope request, session, or application inside regular code, you need attributes. These objects provide information during the servlet's execution and can be used to communicate between scopes and servlets. You may need to pay attention to which attributes have been added or removed to a given scope. For this purpose, the servlet specification provides listener interfaces. These receive notification when events related to a web application occur. To respond to this notification, you must create a class that implements the corresponding listener interface and specify the class name in the deployment descriptor. Then, the servlet container will call the appropriate methods on objects of this class when the events occur. In this section, we'll cover the process of adding and removing attributes and show how to listen to these operations from inside your code. 6.2.1 Adding and removing scope attributes. You can add attribute information to context objects, session objects, and request objects. Fortunately, each of these classes contains the same 4 methods for performing attribute operations. These are listed in Table 6.2. Table 6. 2 methods for getting and setting scope attributes. Object getAttribute string name returns the attribute object associated with the given name. Enumeration getAttribute names returns an enumeration of the names of the scope's attributes. Void setAttribute string name object associates the object with the scope and identifies it with a string name. Void remove attribute string name removes the attribute from the scope. The first 2 methods return objects added to the specified scope. You need to keep 3 important points in mind. HTTP servlet request attributes reset after each request, but session attributes are available to any servlet in the application that receives a request as part of the session. Any attribute associated with the context is available to all servlets in the application. You can only associate one attribute with a given name. Before setting an attribute for a scope, you need to acquire its corresponding scope object. For example, if you want to add a username to a session, you could use HTTPSession =rec. Get session true. Session. Set attribute username, Joe Programmer. This process is straightforward and works similarly for requests and servlet contexts. 6.2. Listening to attribute events. Now that you understand how to add and remove attributes from scope objects, we need to show you how to receive these attribute events. Each scope context, session, and request provides different listeners and events for keeping track of attributes. In this section, we'll look at each of them, listening to request attribute events. If you need to keep track of events involving the addition or removal of request attributes, you should create a class that implements the servlet request attribute listener interface. This class will respond to attribute events as long as the request hasn't left the application's scope. Table 6.3 lists the methods available for handling these events. Table 6.3 Servlet request attribute listener methods. Void attribute added servlet request attribute eventser. Called when an attribute is added to a request. Void attribute remove servlet request attribute eventser. Called when an attribute is removed from a request. Void attribute replaced servlet request attribute eventser. Called when an attribute is replaced in a request. These methods are simple to understand. When you add an attribute to a request, the attribute added method will execute with information taken from the servlet request attribute event. The attribute removed method will activate when an attribute is removed from a request. An attribute replaced will function when an attribute's value is changed. Listening to session attribute events. 3 listener interfaces are available for keeping track of sessions and their attributes. HTTP Session Attribute Listener, HTTP Session Binding Listener, and HTTP Session Activation Listener. We'll cover each of them in Chapter 8, when we discuss the overall framework of session operation, listening to context attribute events. The ServletContext attribute listener interface is used to receive notifications about the changes to the attribute list of a servlet context. It has 3 methods: as shown in Table 6. 4. Table 6. 4 ServletContext attribute listener methods. Void attribute added ServletContext attribute event SCA, called when a new attribute is added to the servlet context. Void attribute removes ServletContext attribute event SCA, called when an existing attribute is removed from the servlet context. Void attribute replaced ServletContext attribute event SCA, called when an attribute of the servlet context is replaced. To use this capability, write a class that implements the interface and specify the name of the class in the deployment descriptor. The servlet container will call its methods automatically when relevant events occur. In addition to these attribute listeners, the servlet specification provides interfaces for keeping track of the servlet's lifecycle. These are important to understand, and we'll cover them in the next section. 6. 3 Servlet lifecycle events and listeners. We saw in the previous section that the servlet container creates events whenever an attribute is added to or removed from a scope object. Similarly, it creates events whenever these objects are created and destroyed. Many times, it is useful to pay attention to these events. For example, we can log an entry in the log file when the context is created, or we can page the support people when the context is destroyed. The servlet specification 2.4 defines the 3 listener interfaces that make this possible. 6. 3. 1 JavaX. Servlet. ServletContext listener. This interface allows the developer to know when a servlet context is initialized or destroyed. For example, we might want to create a database connection as soon as the context is initialized and close it when the context is destroyed. Table 6. 5 shows the 2 methods of the ServletContext listener interface. Table 6. 5 ServletContext listener methods. Void context destroyed ServletContext event SCE, called when the context is destroyed. Void context initialize ServletContext event SCE, called when the context is initialized. Implementing the interface is rather trivial. Listing 6. 1 shows how we can write a class that implements the interface in order to use these notifications to open and close a database connection. Listing 6. 1 implementing ServletContext listener to create a database connection package com. AppSync. Import JavaX. Servlet. Import Java. SQL. Public class by ServletContext listener implements ServletContext listener public void context initialize ServletContext event SCE try connection equal. Create connection to database SCE. getServletContext. Set attribute connection C. Catch exception E. Public void context destroyed ServletContext event SCE try connection equal connection SCE. getServletContext. Get attribute connection C. Close. Catch exception E. In listing 6. 1. We create a database connection in the context initialize method and store it in ServletContext. Since ServletContext is accessible to all of the servlets of the web application, the database connection is also available to them. The contextDestroyed method will be called when the servlet container takes the web application out of service and is thus an ideal place to close the database connection. Notice the use of the ServletContext event object that is passed in the contextInitialized and contextDestroyed methods. We use this object to retrieve a reference to the ServletContext object of the web application. ServletContext event extends Java. Util. Event object. 6. 3. 2 JavaX. Servlet. HTTP session listener. HTTP session listener contains the same methods and capabilities as ServletContext listener, but provides notification whenever a session is created or destroyed. Like the listeners used for session attributes, we'll cover this important interface in Chapter 8, when we go over the process of session operation. 6. 3. 3 JavaX. Servlet. HTTP servlet request listener. The last listener interface we'll present keeps track of the lifecycle of an HTTP servlet request. It receives notification whenever a request comes into scope. Table 6. 6 lists its methods. Table 6. 6 servlet request listener methods. Void request destroyed servlet request event SCE. Called when the request is destroyed. Void request initialize servlet request event SCE. Called when the request is initialized. It's important to inform the web container about your listener classes. This involves setting parameters within the deployment descriptor. We'll investigate this next. Quizlet. Q. Which application event listeners are notified when a web application starts up? A. When the application starts up, the servlet context of the application is created. Therefore, only servlet context listeners are notified. 6. For adding listeners in the deployment descriptor. We can configure the properties of a web application context by using the deployment descriptor. The following is the definition of the web app element. You don't have to memorize this definition, but it's helpful to see all the elements in one place. Element web app icon, display name, description, distributable, context param, filter, filter mapping, listener, servlet, servlet mapping, session config, my mapping, welcome file list, error page, tglib, resource envref, resource ref, security constraint, login config, security role, env entry, ejb ref, ejb local ref. The properties of the web application are accessible through ServletContext. Since the properties apply to all of the components of a web application, it is logical that the elements used to configure the properties come directly under the web element. Let's look at these elements briefly. Display name defines a short name that can be used by development tools, such as IDEs. Description defines the usage and any important information that the developer might want to convey to the deployer. Distributable indicates that the application can be distributed across multiple JVMs. Context param specifies initialization parameters for the web application. It contains a param name, a param value, and an optional description element. In section 6.1, we saw how the ServletContext initialization parameters can be used to create a database connection. The following lines specify a dburl parameter used by a servlet. Context param name, dburl, param name, param value, JDBC, ODBC, misclog, param value, context param. We can have as many context param elements as we need. Listener specifies the classes that listen for the application events that we discussed in section 6.2. It contains one and only one listener class element that specifies the fully qualified class name of the class that implements the listener interface. The following lines show how we can configure two classes that implement the ServletContext listener and ServletContext attribute listener interfaces. Listener, listener class, AppSync. My ServletContext listener. Listener class, listener. Listener, listener class, AppSync. My ServletContext attribute listener. Listener class, listener. Observe that we did not specify which class should be used for which event. That is because the servlet container will figure that out on its own. It instantiates the specified class and checks all the interfaces that the class implements. For each relevant interface, it adds the instance to its list of respective listeners. The container delivers the events to the listeners in the order the classes are specified in the deployment descriptor. These classes must be present in the webinf classes directory or packaged in a jar file with other servlet classes. Note you can also implement multiple listener interfaces in the same class and configure just this class to receive the various notifications through the methods of the respective interfaces. In this case, you will need only one. Listener. Element in the deployment descriptor. The servlet container will create only one instance of this class and will send all the notifications to this instance. Quizlet. Q. You have written a class named myServletRequestListener to listen for servlet request events. How will you configure this class in the deployment descriptor? A. By adding a listener element in the deployment descriptor as shown here. Web app. Listener. Listener class. My session attribute listener. Listener class. Listener. Web app. 6. 5 web applications in a distributed environment. An industrial-strength web application is expected to service thousands of simultaneous users with high reliability. It is common to distribute the applications across multiple server machines that are configured to work as a cluster. Server applications, such as the web server and the servlet container, are spread over these machines and thus work in a distributed mode. For example, one logical servlet container may actually run on multiple JVMs on multiple machines. Distributing an application has the following advantages. Failover support. If a server machine breaks down, another server machine can take over transparently to the users. Load balancing. Requests are assigned to the least busy server of the cluster to be serviced. Distributing an application is not an easy task, though. Configuring the machines and the servers to work in a cluster is quite complicated. Moreover, the servlets need to be designed to run within the constraints imposed by a distributed environment. More often than not, it is easier to upgrade the machine than to distribute the application across multiple machines. However, certain requirements, like failover support, can only be met by clustering. Many assumptions that we make while developing web applications for a single JVM no longer hold in a distributed environment. For example, we cannot assume that there is only one instance of a servlet. There may be multiple instances of a servlet running under different JVMs, and so we cannot use static or instance members to share data. We cannot directly use the local file system. The absolute path of the files may be different on different machines. We also have to keep the application state in the database instead of a servlet context, because there will be different servlet contexts on different machines. The Java servlet specification helps us by guaranteeing the behavior of some of the important aspects and features of a servlet container in a distributed environment. 6. 5. 1 behavior of a servlet context. Each web application has one and only one servlet context instance on each JVM. The servlet context for the default web application, however, exists on only one JVM, that is, it is not distributed. On the exam, you will find questions based on the following points regarding the behavior of a servlet context in a distributed environment. Servlet context attributes set on one JVM are not visible on another JVM. We must use a database or the session to share the information. A servlet container is not required to propagate servlet context events and servlet context attribute events to different JVMs. This means that changes to the servlet context in one JVM may not trigger a method call on a servlet context listener or a servlet context attribute listener in another JVM. Servlet context initialization parameters are available in all of the JVMs. Recall that servlet context initialization parameters are specified in the deployment descriptor. Quizlet. Q. Your web application uses a servlet context listener to page support personnel whenever it goes down. What would be the impact on this functionality if the web application were deployed in a distributed environment? A. There will be no impact on this functionality. Because an instance of servlet context will be created on all the servers, the support personnel will be paged whenever any instance is destroyed. Q. You maintain a list of users who are logged into the system in servlet context. You print the list of these users upon request. How would this functionality be affected if your web application were deployed in a distributed environment? A. This functionality will not work properly in a distributed environment. Remember that each server machine will have a separate instance of servlet context. Therefore, A servlet context will only know of the users who logged in through the server machine on which it resides. Obviously, a request to print the list of users will show only a partial list of the users. 6. 5. 2. Behavior of an HTTP session. In a distributed environment, the semantics of an HTTP session are a little different than those of a servlet context. The specification mandates that requests belonging to a session must be serviced by only one JVM at a time. However, the container may migrate the session to another JVM for load balancing or failover. You should remember the following points regarding the behavior of an HTTP session in a distributed environment. An HTTP session can reside on only one JVM at a time. A servlet container is not required to propagate HTTP session events to different JVMs. Attributes of a session that implement the Java I/O serializable interface are migrated appropriately when the session migrates. This does not mean that if the attributes implement the read object and write object methods, they will definitely be called. A container notifies all of the session attributes that implement the HTTP session activation listener interface when it migrates the session. A container may throw in a legal argument exception in the setAttribute method of HTTP session if the attribute is not serializable. 6. Summary. The servlets of a web application share the application's environment through the methods of the ServletContext object. When a web application is loaded, ServletContext is initialized using the parameters that have been defined in the deployment descriptor. In this chapter, we learned how to use the initialization parameters of ServletContext. Listener interfaces are implemented in order to receive notifications of certain events in a web application. We discussed the uses of the ServletContext listener, the ServletContext attribute listener, the Servlet request attribute lister, and their configuration in the deployment descriptor. A web application can be distributed across multiple servers to improve performance and reliability. We discussed the ways that ServletContext and HTTP session function in a distributed environment. You should now be able to answer the questions about ServletContext initialization parameters, the application event listener classes, and the behavior of ServletContext and HTTP session in a distributed environment. In the next chapter, we'll explore the topic of filters. 6. 7 Review questions. 1. Which of the following methods will be invoked when a ServletContext is destroyed? Select 1. A context destroyed of JAVAX. Servlet. ServletContext listener. B. Context destroyed of JAVAX. Servlet. HTTP ServletContext listener. C. Context destroyed of JAVAX. Servlet. HTTP /servlet context listener. D. Context destroyed of JAVAX. Servlet. HTTP HTTP ServletContext listener. Answer. Explanation. Remember that the concept of ServletContext applies to all the servlets and not just HTTP servlets. Therefore, interfaces related to ServletContext belong to the JAVAX. Servlet package. 2. Which of the following methods will be invoked when a ServletContext is created? Select 1. A context instantiated of JAVAX. Servlet. ServletContext listener. B. Context initialized of JAVAX. Servlet. ServletContext listener. C. Context initiated of JAVAX. Servlet. ServletContext listener. D. Context created of JAVAX. Servlet. ServletContext listener. Answer. B. Explanation. On the exam, you will be asked questions that require you to know the method names for all the methods of the Servlet API. As in this question, the options may be very confusing. 3. Consider the following class. Import JAVAX. Servlet. Public class myListener implements ServletContext attribute listener public void attribute added ServletContext attribute event SCAD system. Out. Print on attribute added. Public void attribute remove ServletContext attribute event SCAD system. Out. Print on attribute removed. Which of the following statements about the above class is correct? Select 1. A. This class will compile as is. B. This class will compile only if the attribute replaced method is added to it. C. This class will compile only if the attribute updated method is added to it. D. This class will compile only if the attribute changed method is added to it. Answer. B. Explanation. ServletContext attribute listener also declares the public void attribute replaced ServletContext attribute event scab method, which is called when an existing attribute is replaced by another one. 4. Which method is used to retrieve an attribute from a ServletContext? Select 1. A string getAttribute int index. B. String getObject int index. C. Object getAttribute int index. D. Object getObject int index. E. Object getAttribute string name. F. String getAttribute string name. G. String getObject string name. Answer. E. Explanation. Since we can store any type of object in a servlet context, the getAttribute method returns an object. You can then cast the returned object to whatever type you expect it to be. 5. Which method is used to retrieve an initialization parameter from a servlet context? Select 1. A. Object getInit parameter int index. B. Object getParameter int index. C. Object getInit parameter string name. D. String getInit parameter string name. E. String getParameter string name. Answer. D. Explanation. Initialization parameters are specified in the deployment descriptor. Since we can only specify strings in the deployment descriptor, the getInit parameter method returns a string. 6. Which deployment descriptor element is used to specify a servlet context listener? Select 1. A. Context listener. B. Listener. C. Servlet context listener. D. Servlet context listener. E. Servlet context listener. Answer. B. Explanation. All the listeners that are specified in the deployment descriptor are specified using the listener element, listener class, ABC, my ServletContext listener class, listener. The servlet container automatically figures out the type of interface that the specified class implements. 7. Which of the following web.xml snippets correctly specify an initialization parameter for a servlet context? Select 1. A. Context param, name, country, name, value, USA, value, context param. B. Context param, param name equal country value equal USA, context param. C. Context param name equal country value equal USA, context. D. Context param, param name, country, param name, param value, USA, param value, context param. Answer. D. Explanation. Initialization parameters for the servlet context are specified using the contextparam element, which contains exactly one param name and exactly one param value element. 8. Which of the following is not a requirement of a distributable web application? Select 1. It cannot depend on the notification events generated due to changes in the servlet context attribute list. B. It cannot depend on the notification events generated due to changes in the session attribute list. C. It cannot depend on the notification events generated when a session is activated or passivated. D. It cannot depend on the notification events generated when servlet context is created or destroyed. E. It cannot depend on the notification events generated when a session is created or destroyed. Answer. C. Explanation. A servlet container may not propagate servlet context events generated when a context is created or destroyed, and servlet context attribute events generated when the attribute list of a context changes to listeners residing in other JVMs. This means that your web application cannot depend on these notifications. The same is true for events generated when a session is created or destroyed and when the attribute list of a session changes. A session resides in only one JVM at a time, so all the session attributes that implement HTTP session activation listener receive notifications when the session is activated or passivated. 9. Which of the following is a requirement of a distributable web application? Select 1. It cannot depend on ServletContext for sharing information. B. It cannot depend on the send redirect method. C. It cannot depend on the include and forward methods of the request dispatcher class. D. It cannot depend on cookies for session management. Answer. Explanation. Since each JVM has a separate instance of a ServletContext for each web application except the default one, the attribute set in a ServletContext on one JVM will not be visible in the ServletContext for the same application on another JVM.